Question 11. The equation of the curve is such that dy dx is equal to 6x squared minus 30x plus 6a, where a is a positive constant. The curve has a stationary point, this one here, part A. Find the value of a. You know that for stationary points, dy dx is equal to what? 0. So for stationary points, then dy dx is equal to 0. So I will get the 6x squared minus 30 of x plus 6a. Okay, I will substitute the value. Actually, where there is x, I will put a. For x is equal to a, then we shall have 6a squared minus 30 of a, then plus 6a is equal to 0. Divide all through by 6. Divide all through by 6 to simplify this quadratic equation. Okay, that means here we shall get a squared, then minus 5 of a, then here plus a, which is equal to 0. Actually, we can simplify this one. It is minus 4a. So a squared minus 4a is equal to 0. So a is common, then a minus 4 here, meaning a can be equal to 0 or a can be equal to 4. Okay, and they say that it is a positive constant, so we can't take the 0. That means a is equal to 4. And then next, determine the nature of the stationary point. That means we need to differentiate the second time. Okay, so first of all, when we differentiate the second time, the second derivative here, if we differentiate the second time and then we substitute the value of x, if the second derivative is a positive, then that means the stationary point is a minimum. And then if the stationary point, the second derivative is a negative, then the stationary point is a maximum. So the second derivative, right from here, that one will be 12x, because you drop the power and then you reduce it by 1, then minus 30. Okay, then from there, remember x is the coordinate. We have the x coordinate here, which is equal to a. You see that? So I will say at that point 4, negative 15, our x is a 4. So the second derivative here is going to be 12 times 4, which is 48. 48 minus 30, this one gives us 18. 18 is greater than 0. So that means that the stationary point is minimum. As simple as that. Then part C, find the equation of the curve. That means we need to integrate. So if our dy dx is equal to 6x squared, then minus 30 of x plus 24. Why have I written it like that? Because our a is a 4. So times 6 times 4, you get the 24. Okay, that means now our y is going to be equal to the integral of what was differentiated. So minus 30 of x, then plus the 24, then with respect to x. Remember, you increase the power by 1, so this will be 6x cubed over 3, which simplifies to 2x cubed, and then minus 30x squared divided by 2, that will be 15x squared, and then plus the 24 of x. But then we need to put a constant because we don't know the constant that disappeared when they differentiated. Okay, and then that constant can be got by that point that is on the curve. Okay, and if a point lies on the curve, that means its coordinates must satisfy the equation of that curve. So the y coordinate here is negative 15, then the x coordinate is a 4, so we cube this one, then 15, then 4 squared, then plus the 24 times 4 plus c. So we have negative 15, then minus 4 cubed, 64 times 2, that is 128. So when it crosses, it's a minus. And then this is 16 times 15, that will be 240. So when it crosses, it's a positive. So positive 240. And then this one is 96. So when it crosses, it gives us a minus. So this one will give us the C. Now what is the value of C here? Negative 15 minus 128, then plus 240, then minus 96. This one gives us a 1. So meaning the equation of the curve is y, which is equal to 2x cubed minus 15x squared plus 24 of x, then plus 1. As simple as that. Then part D, find the coordinates of the other stationary points on the curve. Coordinates of any other stationary points on the curve. Now remember, for stationary points, dy dx is equal to 0. And our dy dx is 6x squared, then minus 30x, then plus the 24. Okay, this one we have to equate it to 0. Already we have seen it here, our dy dx. Okay, so we just equate it to 0. Now this one can be simplified. If I divide all through by 6, here I will get x squared, here I will get 5x, and then here I will get 4. This is a quadratic equation we can easily solve. Two numbers, when I multiply them, I get 4, but when I add them, I get negative 5. That will be negative 1 and negative 4. Not so. That means we shall have x minus 1 and then x minus 4, which is equal to 0. So by equating each of these factors to 0, that means x can be equal to 1 and also x can be equal to 4. But one of the turning points, the stationary points, we have seen that it is a 4. That means we are going to consider this one. For x is equal to 1, what will be the y coordinate? Then we substitute in this equation we have gotten here. So that means if you got this one wrongly, then there is no way you're going to get this one right. So this will be 2 into 1 cubed minus 15, then 1 squared, then plus 24 times 1, then plus 1. This will be 2 minus 15, that will be negative 13. Negative 13 plus 1, that will be negative 12. Then negative 12 plus 24, that one will give us a 12. Not so? Yes, so that one gives us a 12. So that means the coordinates of the other stationary point, we are going to have 1 and then 12. As simple as that.